Hello, my name is Vladimir. I'm a front-end developer and currently I'm working for Zamat. Zamat is an open source help desk ticketing software. We're proud of our open source philosophy, so everyone can run Zamat on their own servers, and to that we have a constantly growing community. I'm also a core team member in Vitest, a test runner that we also use in Zamat. And today I'm going to talk about how Vitest improves your developer experience. Vitest was originally developed as an alternative to Jest for Vite applications because Jest didn't have support for asynchronous transforms and many of Vite's API. It's built on top of Vite Node package, which is a Node.js runtime that uses Vite to transform files before running it. But right now, Vitest is a fully fledged test runner like Jest, Ava, Tap, Mocha, or any other test runner. It tries to be feature-rich without unnecessary configuration. It provides ESM, TypeScript, and JSX support out of the box, thanks to Vite. Here are some of the Vitest features. Vitest uses Vite's configuration file, including transformers, resolvers, and plugins, so you have the same code in development, production, and in testing. Vitest has smart and instant watch mode. In fact, it's so fast that we had to add an artificial delay before displaying result in a terminal. It uses Vite's module graph to detect imports, which makes experience similar to HMR in your browser. You can run Vitest to test your components using your favorite framework, like Vue, React, Svelte, and many more. If your framework supports Vite, it supports Vitest. Vitest comes with a chai built-in for assertions. It means you can use its assert, should, or expect API with Vitest. But for easier migration, we also provide Jest's expect compatible API, like to be, to equal, to match, and so on. To mock DOM API, Vitest provides JSDOM and HappyDOM built-in environments that you can also extend. For coverage, Vitest provides reporting with C8 and Istanbul out of the box. Also, Vitest has a unique among front-end test runners feature called in-source testing, which was inspired by Rust's module testing. And we also provide experimental benchmarking feature via a TinyBench package. So now, when you know what Vitest is, let's see it in action. Here we have a Vue3 component using script setup syntax, as you can see here, with a simple test that renders it and checks some output. This component, as we can see in a snapshot, has a div and a button that increases its multiplier. This snapshot is generated by Vitest, as you can see here in the first line. The snapshot feature is equal to Jest snapshot, so if you are migrating from Jest, you should be fine. So let's run this. I am running it with UI flag. So as you can see, Vitest provides your beautiful UI to view and interact with your tests. And as you can see, it doesn't show you rendered component, which we can see here, because this UI is not meant for this. But we have a package called Vitest Browser that enables viewing it. But it's in an experimental stage, and I didn't manage to make it work for this demo, unfortunately. But by the time you're watching this, it will probably work. This UI provides you with a way to see a report. So if this had an error, you would see an error here. This UI also allows you to filter your tests to run only filtered tests, to filter local tests. You can also, but this test only has one. So, and a feature that I like the most is module graph. You can see here, this is quite a simple test, so module graph is quite small, but for bigger applications, it's very useful to see how all your files are interacting with each other. But one of the best features here is that you can edit your tests right in the browser. I save this and I can see an assertion error happened. and I can see where it happened, and I can also see it in a report. I can click open an editor, and it will open this this tab for me. So as we can see here, it expects when we are multiplying 3 by 2, we expect 6, but here we have a 4 multiplied by 2. So let's revert this to 4 for now. Now our test runs fine. Since Vitest was made to fix Jest issues, we provide Jest compatible API for easier migration. As you can see here, we are using toContain and toMatch snapshot matchers, which are fully compatible with Jest. But not only do we support expect API, we also support Jest API, Jest global variable. If you've ever written code like this, this was a little spoiler. You can use the same in Vitest, but we don't by default we do not expose Jest variable, but we have our own variable with the same API, public API. It's called V or Vitest. You can use which one you prefer the most. We usually recommend using V. So if you have if you want to see how your tests are running under Vitest, but you don't want to migrate from Jest right away, you can use this little trick. You can assign a global this Jest variable to V, and all your methods should work fine. Vitest still has some differences. We provide migration guide in our docs documenting all these differences, but for the most part it should work. And we also provide you, as you can see here, Jestfn is a spy. So Vitest also has spies which are fully compatible with Jest spies, with the same methods and the names and so on and so forth. But probably the best feature of Vitest is its watch mode. Let's remove this. It runs only the affected tests. So for example here, as you can see, it showed me rerun 4. When I edit this test, it will rerun only this test. But this is not where it ends. If we are editing this component here, for example, we can add a new button that adds a multiplier by 2, incremented by 2. Now we can see that our test has failed because snapshot that we had is not equal to the snapshot that it generates now. So for now we can comment it out. Let's now test our new button. Here I will add a new test like this. I don't think this is the best way to do it. I would probably get it by the text inside, but for now I think it's fine. We're triggering it. We trigger it now, and we expect. I think 4 should be incremented by 2, and we now have 6, which is 24. We save this test, and it runs fine. By the way, as you can see, the actual duration of test is 132 milliseconds, which is quite fast. We think that this experience is preferable, so we enable watch mode by default if you don't override it with a run flag. So I think this is all for front-end part, but you don't have to use Vitest with front-end frameworks. In fact, Vitest is Node.js test runner by default. So as you can see here, this is a simple Node.js application, just a square root function. We are testing here that the values are correct. This, as you can see in the configuration file, nothing is configured, so this is by default. Now let's run this. And as you can see, everything is passing. Vitest has a concept of contexts, which was inspired by fixtures from Playwright. Contexts are an object that is passed as a first argument to your test. So here we can see that this has a type of test context. By default, it has meta and expect, so you can have local expects. This is useful for concurrent testing. If you have, for example, if you are doing too much snapshot inside a concurrent test, but you can put things here. For example, we can use before each function to put something on the context. Expect context. I'm sorry, context full to be 1. Now it says the tests are passing, but the TypeScript shows us an error. To bypass this error, we need to define an interface. Foo is a number. We can pass down this interface as a generic. So we will need to pass it down for each test that we need a context. We can also define it globally. For example, we can do declare module Vitest interface text context. Thank you. So now it knows that every test has this context. Every test in your entire suite will have this context. There is a simpler way with using TypeScript. For example, you can do a foo test is test with context. Now we can remove this. Probably should do it here. But now we can do foo test and it will have this context. It will know the context of this test. But beware that this is incompatible with jest. For jest had a done callback here. So if you are calling this here, as you can see, it's deprecated. If you are calling it here, you will get an error. Context is not. I'm sorry. Context is not defined. Is here. It's a test now. If you are calling done here, it will call you that it's deprecated, and you should use a promise instead. So to emulate a done callback from jest, you can return a promise like this, and the test will pass. Each test has its own context. So, for example, you cannot access a context in before all callback. Doesn't have a context, but it does, by the way, have an access to suite, current suite, or a file, whichever it is. You can access its name, for example. I think it has a file path. Yeah, I think this is all I wanted to talk about with contexts. There is also one cool feature that Vitest has. It's called Vitest changed. So as you can see here, we edited one file. We changed one file, a test, and we don't want to run the whole suite of tests. So we can do what we can do is run test changed, and this is Vitest changed command, and it will see all the files that are changed and run only tests that are imported by it, or the tests itself. For example, here we edited the test and we see the test changed. If we roll back, we should see nothing is changed, so no tests will run. But the cool feature is what if we added here, for example, a console log, an empty string. We can now run test changed and it will run a basic test because this function is imported here, which is pretty cool. Now let's talk about in-source testing. This feature allows you to write your tests inside your source code. Why would you do that, though? Well, this feature could be useful for a number of things. For example, for unit testing small scoped functions or utilities, like here on the slide. For example, if you have a collection of files with a single function each, you can keep your tests inside that file. It's also useful for prototyping. if you are writing tests alongside your program, you might be more focused on the functionality itself. You can also make inline assertions right inside your program. For example, you can test an intermediate value in your function. It's also useful to make an assertion inside of a private method, for example, that you cannot export, or inside a constructor. It's also useful to test functions that you want to keep inside a specific module without exporting it. For example, if add function had some kind of a helper that was defined here, you could have tested this helper in isolation right inside this module without exporting it publicly, which might be the most useful case here. But we do recommend you to use separate test files for more complex tests like components or end-to-end testing, because they usually require more complex setup, like using libraries to render set components. For example, here, this code will be stripped out from your production code because it's guarded by import meta Vitest, which will be undefined or false, whichever you want. But if you are using some kind of an import screen, for example, from the testing library DOM, testing DOM has this like React. This might be bundled with your production code, so even if you use it only here. Because I think you need a side effect property in your package.json, or in the package.json of the module itself, to specify that it can be safely removed. I think this is all for features that I had time to show you, and let's talk about what is coming next for Vitest. Since Vitest provides TypeScript support out of the box, we thought it would be a good idea and makes sense to also provide support for type testing also out of the box. So we have an OpenRFC, which you can leave a comment in. Currently, we are thinking about providing 2 APIs for type testing, like we do for regular testing. Sorry, which is expect and assert. So there will be an expect type of function, which exposes similar to expect matchers like to match, to equal type, and so on. And it is inspired by expect type package. And we also think that we will have an assert type function, which is inspired by TSD. But stay tuned for that. It's not implemented yet. It's only in an RFC stage. But what is implemented is benchmarking. It's already implemented, but we are thinking that we can do better. For example, currently we are not happy with the result output. We are thinking that API could be improved and standardized before this feature loses its experimental flag. Vitest also, as I said before, provides a Vitest browser package for previewing your tests in a browser, but currently it doesn't support running tests in CI, but it can be useful to debug your failing tests. This feature is not ready for production use and may even not work for you at this stage, but we always welcome feedback. So feel free to open an issue about this feature right now. We also want to improve documentation. The current state of documentation is that it was written before Vitest left experimental stage, and it focuses more on migration and Jest API, and doesn't help new people get accustomed to Vitest itself. So this is all I wanted to talk to you about. Thank you for listening to my talk.